Hello friends, today I'm going to talk about the chapter called progressions. In all my lectures you will understand one thing, that I'm not going to solve many problems. I am going to discuss only the theory and the concepts behind these topics. I am 100% sure that if you are very clear about the concepts, then you will yourself able to solve some problems. Although at the end of my lectures, I am going to solve few problems, just an illustrative. Okay. But I am of my all the experience of 25 years has told me one thing, that if the students are very clear about the concepts, then they can themselves manage to solve the problems. So if you want to clear your concepts about any subject, any topic in mathematics, then only you should join my lectures. Okay, fine. So now what is the progression? Progression means, let us take a set of natural numbers, So I am writing it in a vertical order. So this is 1. This is 2, this is 3, this is 4, this is 5, this is 6, and it goes on. So there is no end to this set of natural numbers. Somewhere I will call it n, and it goes on. So this is a set of natural numbers with which we are very, very familiar. Now what we are going to do is, for every natural number, I am going to associate some real number. So for example, 1, I will associate 1 only. Okay. 2, I will associate 3. 3, I will associate 5. 4, I will associate 7. 5, I will associate 9. Now, you are getting a clear picture of what I am doing. If it is 1, then it is 1. All these numbers are odd numbers. Odd numbers. This is called first odd number. This is a first odd number. First odd number. What is this? Second odd number. Third odd number. And so on. So in general, there will be nth odd number. Nth odd number. Right? So for every natural number which will arrive here, I am associating one real number, and this I will denote it by just writing 1 followed by 3 followed by 5 followed by 7 and so on. I don't have to bother about writing this 1, 2, 3, 4 because I know this is the first term. So I'll call this number is associated with 1, natural number 1, so I call it T1. This will be called T2. This will be called T3. This will be called T4. And if it is nth natural number, then this will be called Tn. And T1 means actually first term. First term. This is second term. This will be nth term. Nth term. Correct? So that is how the sequences are denoted. Most of the time it is understood that they are associated with 1, 2, 3, 4. So we don't have to write it. We just write sequentially one by one, and that is called terms. Okay. Now, let us take the first type of sequence that we are going to study. There are various types of sequences. We will not go into the details of how many types are there. But right now, I am interested in only one type of sequence, which is very, very simple and which is very, very important to our life also. That is called arithmetic progression. Arithmetic progression. Now, it is in short called AP. Arithmetic progression is called arithmetic progression is in short is called AP. Now, how does this sequence is created? Actually, it's very, very simple. You start with any number. Start with any number. Start with any number. Any real number. Start with any real number. Let us say 5. Fine. And go on adding the same number. Choose any other number. Say 3. Okay. So I have selected 3. So I keep on adding 3 to this. So 5 plus 3 will be 8. 8 plus 3 will be 11. 11 plus 3 will be 14. 14 plus 3 will be 17. 17 plus 3 will be 20. So this goes on. So I started with 5 and kept on adding same number again and again, and kept on getting the next term. So this will be T1, this will be T2, this will be T3, T4, T5, T6. So what is the speciality of this type of sequence? If you take the second term minus first term, the difference is 8 minus 5 is what? 3. 11 minus 8 is what? 3. 14 minus 11 is what? 3. So even if it is say T99 and T100, so difference between T100, I am 100% sure that T100 minus T99 will be also what? 3. So what remains constant here is the difference between two consecutive terms. T1, T2 are consecutive terms, T2, T3 are consecutive terms, T3, T4 are consecutive terms, T5, T6 are consecutive terms, T100 and T99 are consecutive terms. In general, if the next term is denoted by Tn plus 1, then the previous term will be Tn. So Tn plus 1 minus Tn, this difference will be always constant, never change. Correct? So Tn plus 1 means n, you can replace n by any natural number. So suppose I replace n by 8. So 8 plus 1 will be 9. So this will be 8. So T9 minus T8, right? So this is a definition. This defines the kind of progression that we are going to study. So how does it define? Arithmetic progression is defined as a sequence of terms such that the difference between the consecutive terms is always constant. Correct? So that is our definition. So arithmetic progression is a sequence of numbers in which difference between any two consecutive terms is constant, never changes, constant. Now this constant, will be denoting it by a number called D because it is called common difference. This D is called common difference. So these are the specialties of arithmetic progression. So we start with any number, but we need two things in order to build this arithmetic progression. First is the starting number. So this starting number, right? And then we need what? A common difference. And we can immediately construct an arithmetic progression. So what we need for building up an arithmetic progression is, we need only two things. We need the number to start with. It is denoted by A and actually it is T1. So T1 is always equal to A and common difference is D. So there are only two numbers required. First term and the common difference. So what will be T1 then? T1 will be A, it is given, right? Then what will be the next number? T2 will be A plus D, correct? T3 will be what? A plus 2D, because A plus D, it is a, just add D to the previous term. So it is, if I add D here, then it is A plus 3D. Now, I can go on writing like that. So I have to understand the relation between these numbers and these numbers. So you can see here, 2, here it is nothing but that is 1. So 3, 2, here it is 4, this is 3. So you can clearly see that there is a difference of 1 between these two numbers. So if Tn is the nth term of this progression, then it will be A plus, I will have to multiply D by the number 1 less than n. So 1 less than n means n minus 1. multiplied by d. So this is a very important formula. We got a formula for nth term of an arithmetic progression, right? So nth term of an arithmetic progression is given by Tn is equal to 1 a plus n minus 1d. Now let us see for example. Suppose I started with the previous sequence, that is 5, then 8, then 11, then 14 and so on. So all that I have to do is to identify two things. What is the first number and which number is being added? So what is the first number? That is denoted by A. A is 5 here. And what is the common difference? D, which is equal to 3 here. Correct? So which means I can immediately find out Tn. So Tn is actually equal to what? 5 plus n minus 1 into 3. That means it is 5 plus 3n minus 3, little bit of simplification, 2 plus 3n. So this is the nth term of the sequence. Now you have got a formula for nth term. So if you want to find out, say, T99, it's absolutely simple. It is 2 plus, you just replace n by 99 and you'll get 99th term. So it is 2 plus 27 carried on 2, again 27 plus 2, which is equal to 29, correct? So that means the answer is going to be 299. 299. That will be the nth term of the progression, or 99th term of the progression. So therefore, this is how the formula is to be applied. So I will give you some more examples. Okay. So let us see. So let us take progressions like this. Say 1, 3, 5, 7 and so on. Sequence of odd numbers, right? Now here, what is the first term? A, 1. What is the common difference? 2. You can see clearly. So what is Tn here? Tn means nth odd number. What will be nth odd number? 1 plus n minus 1 into 2. So therefore 1 plus 2n minus 2, which means 1 plus, which means 2n minus 1. So if I want to find out 100th odd number, T100 will be 2 multiplied by 100 minus 1. So that is 200 minus 1. So it is 199. Very easy, correct? So that is how you can find out the nth term of a sequence. Okay. Let us take some more examples. For example, let us say this one. Okay. So suppose I got this example, say 3, 0, minus 3, minus 6, minus 9 and so on. Correct? So I just want to illustrate that the common difference can be any real number. It could be positive number, it could be negative number. Here you can see that first number that I started with is 3. And I am subtracting 3 from all the numbers so that I get the next number, right? So D here is minus 3. Fine. So formula will remain same. What is Tn? Tn is equal to A plus n minus 1 into D. Fine. So A is what? 3 plus n minus 1 into minus 3. So what is that? That is equal to 3 minus 3n, correct? And plus 3, which is equal to 6 minus 3n. So that gives me nth term of this particular sequence. Okay. So it may not be positive number. It could be rational also. For example, it could be like this also. 1. The next term is half. The next term is 0. Next term is minus half. Did you get what am I doing? Very simple. I started with 1 and kept on subtracting half from each. So 1 minus half is half. Half minus half is 0. 0 minus half is minus half and so on. So I know here that A in this case is 1. First term is 1, right? And the common difference here is what? Half. Therefore, Tn can be written as A plus n minus 1 into D. So that means 1 plus n minus 1 into half. So that gives you 1 plus n by 2 minus half, which gives you n by 2 plus half. Why? Because 1 minus half is half. So therefore you can of course write it like it is, n plus 1 upon 2. That gives you the formula for the nth term of this particular sequence. Okay, fine. So now, the next thing that we would like to know about arithmetic progression is that, this is a very common example that suppose a person A is applying for a job and his starting salary is, let us say, 500 rupees, and every year he is going to get an increment of 50 rupees, right? So his starting salary is 50, okay? Starting salary is 500 rupees, and every year, that means A is 500 and common difference here is what? A 50 rupees, okay? But remember one thing, that annual increase is there, annual increment. So annual increment means his first salary is 500, and then at the end of first year he is going to get an increment of 50. So what will be the salary of this particular person after 50 years or after 25 years? So I want to find out 25th terms of this particular sequence. So that means T25 is equal to 500 plus 25 minus 1 times 50. That will be his salary after 25 years. Okay. So 500 plus 24 multiplied by 50, correct? Which gives you 500 plus 0, 1200, right? So that means the annual salary at the end of 25 years will be around 1700, correct? But we are also interested in finding out what will be his total income in all these years. What will be his total income in all these years? That means I will have to add all the terms, but this is a monthly salary. Therefore, you will have to calculate his annual income and the increment in the annual income. His annual income will be what? Annual income will be 500 multiplied by 12, and his increment will be 50 multiplied by 12. So that means this is the first term and this is the last term. Okay. So for A is what? A is equal to 60, 0, 0, right? So his first year's income is 6,000. Okay. And every year he gets 600 rupees increment. Okay. So this is roughly the calculation. And if he works for 25 years, then we can always find out his annual income at the 25th year. But we are not interested in that. Throughout his lifetime, how much income he will earn. That means we will have to add all these terms. That means we have to find out sum of his incomes in 25 years. Now, that means, see, what we are going to do is, in the first year, he got an income of 6,000 rupees, right? He got 6,000 rupees in the first year. Then, in the next year, he is going to get 6,600. In the next year, he will get, again 600 will be added to this. So, it will be 7,200 and so on. And like that, I will have to keep on adding his income every year, and then I'll get the total income. This is called sum or series. What is a series? Series is just another sequence that we obtain by adding first n terms of the previous sequence. Okay. So suppose I have a sequence like this. Suppose I have a sequence like this. Let us say A1, A2, A3, A4, A5 and so on till you reach what? N. Any sequence, may not be arithmetic progression. Now, suppose I create something like this. So, I'll call it S1. A new sequence is created out of this old sequence. So, new sequence, the first term is S1 and it is nothing but the first term. So it coincides. Okay. But what is S2? S2 will be A1 plus A2. What will be S3? S3 is A1 plus A2 plus A3. Like that, Sn will be A1 plus A2 plus A3 and so on till you reach what? An. Right? So this is called sequence, original sequence, and this is a series obtained out of it. This is a series obtained, series obtained from this. So therefore, this is another sequence actually, but this sequence is created out of this sequence by adding the nth term, n term or first n term. So S1 means only the first term. So it coincides with the first term here. S2 means I am adding 2 terms of this previous sequence, A1 plus A2. S3 means I am adding 3 terms of this sequence. Sn means I am adding first n terms of this sequence. That looks like this. Okay. And this is called series. And that is why the topic is called sequence and series. Actually, series also is a sequence, but it has got something else to do with, because it requires a summation. Okay. So therefore, now this reminds me a very famous story, which is very famous in mathematics, and it's about one of the legend in mathematician. And what happened was, this fellow was just in second standard, and in second standard there was a teacher. There were 80 students in the class, and the teacher, all over the world teachers are same, like India only, right? So he wanted to go back to his house for some housework, and he wanted to keep these children quiet for some time. So he thought a best trick is what? Give them some kind of a problem which will take hours for them to solve. Now second standard students, so he just told them, he just got up from his chair and said, children, I want you to add numbers from 1 to 100. Now you know how the children learn to add. They'll write 1 here, then they'll add what? 2. So then 1 plus 2, this becomes 3. Then 1 plus 1, like that. Now this is how they were supposed to add, right? Now he knew that if they keep on writing like this, it will take at least 2 or 3 hours for them to complete the answer. Therefore, he was very comfortable. He left his chair and he was about to get out of this class. He had walked up to the door, and suddenly there was one fellow who stood up and said, sir, I know the answer. He says, what? Yes, I know the answer. He says, what? You know the answer. You already done it. So he thought that he is bluffing. So he said, so the answer is 5050. The teacher was thunderstruck. He himself did not know the answer. So he asked him, how did you know that it is 5050? Sir, let me explain. And he explained it like this. He says, sir, you want me to add first 100 numbers, right? So 1 plus 2 plus 3 plus 4, fine. Okay. Now, let us look at the last numbers, So last number is 100, right? The second last number is 99. The third last number is 98, and so on and so forth, right? Now, if you look at these numbers, then take the addition of first and last number. So, first number and last number. What is the total? Sir, it is 101. Okay. Then, sir, why don't you take a second number and second last number like this? Okay. 99 plus 2. What is the total, sir? 101. Then you take third number, and third last number from here. Again, the total is what? 101. So I'll have to keep on adding 101, 101, 101, 101. As many pairs are there. And the total number of pairs, because the numbers are 100, is 50. So therefore, the answer is going to be 50 multiplied by 101. Right? And that gives you what? That gives you 5050. Fantastic answer and fantastic method. So this kind of pattern which was noted by this particular scientist, and his name was Carl Friedrich Gauss. later on, he went on to become one of the greatest mathematicians the world has ever produced. That goes without saying. But he has given you not only sum of first n natural numbers, but he has also given you a method of adding any arithmetic progression. Because this is a property not only for this arithmetic progression, this is a property of all arithmetic progression. Let us look at it like this. Let us write our arithmetic progression in the latest form. That means first number of this arithmetic progression is A. What is the second number, second term? You have to add D. Okay. Now, let us call it last term as L. What is the previous number? It will be L minus D. Okay. Like that. Okay. So, this is A plus D. Now, if you take the next number, it is A plus 2D. And here, the third last number will be L minus 2D, isn't it? Now, you add the first and last. If you add first and last, what will happen? It will be A plus L. A plus L. You take second number and second last number. Again, the total is same because minus D plus D gets cancelled. You will get A plus L. Correct? Then you take third number and third last number. Again, the answer is A plus L. So you keep on adding A plus L, A plus L. How many times? Exactly as many pairs are there. So there are exactly half number of pairs. So therefore, total sum, that is Sn, will be given by half the number, that is n by 2 multiplied by A plus L. Or you can write it like this also, n multiplied by A plus L by 2, which means the answer is nothing but the average of arithmetic mean of A and first and last term and just multiplied by what? N. That gives you Sn. So Sn is equal to, another formula for Sn is n by 2 multiplied by A plus last term. Last term is nothing but Tn. And Tn is given by A plus n minus 1 into D. Therefore, the answer is n by 2 multiplied by 2A plus n minus 1 into D. You can use this formula or this formula, whichever is suitable in whichever situation. So, sum of n terms of an arithmetic progression is given by A plus L by 2 and Sn is given by 2A plus n minus 1 into D. So, let us see what is the sum of first n natural numbers. Use this formula, right? Sum of first n natural numbers. Let us see. Sum of first n natural numbers. It is 1 plus 2 plus 3 and so on till you reach what? N. According to a formula, A is 1 and D is also 1. So Sn is given by n upon 2 multiplied by 2A, that is 2 into 1 plus n minus 1 into D, which is also 1. Therefore, it is n by 2 multiplied by 2 plus n minus 1, which gives you n into n plus 1 divided by 2. Correct? So, if I want to find out the sum of first 100 numbers, it is 100 into 101 upon 2. That is 50 multiplied by. Okay? So, suppose I want to find out sum of first n, these numbers, odd numbers. So, sum of first n odd numbers. Odd numbers, right? So what will be that? That will be 1 plus 3 plus 5 and so on. Last number is 2n minus 1. So what is the total? Very simple. N by 2 multiplied by 2a plus n minus 1 into d. Difference is 2 here. So therefore it will be n by 2 multiplied by 2 plus 2n minus 2. So 2 gets cancelled and you get n square. Very simple. And you can verify What is 1? 1 square. What is 1 plus 3? 4. 2 square. So this is 2 square. This is 3 square. And like that, this will be 4 square and so on. So therefore, sum of n odd numbers is always n square. Very, very important result. Okay. So that is how the arithmetic progression can be added. Okay. So these are the basics about arithmetic progression. Okay.